Hi, this is Mrs McTaggart. In this video we're going to look at the part of the higher differentiation topic where we're going to sketch the graph of the derivative. This is sometimes taught during differentiation, or it can be taught when you start to talk about all the movement of graphs. So let's have a wee look. Okay, so to illustrate how to draw the graph of the derivative, I'm going to start very simple. I'm going to show you this curve here. Now I've given the equation up here in the corner, right? The equation is irrelevant. To draw the graph of the derivative, all you need is the original sketch of the shape, and we are looking at the shape here. Two key facts about this shape is it's got a cubic shape and it's got two turning points, a maximum and a minimum. Now when we differentiate this gives us 9x squared minus 4x minus 2. Now we should be expecting from that a quadratic, a smiley face shaped quadratic like this. So on my next picture I've actually drawn the two together. So this blue line represents the graph of the derivative. Now, a couple of things to point out. Remember I said there was two key important features. The first one was your turning point on the original pictures. Now, the thing to notice is if I trace my turning points up to the axis or down to the axis, that might actually be better in a different colour pen. So if I trace my turning points down to the axis, do you notice that where the turning points used to be on the old diagram now become the roots of the new diagram? Now that's going to be the first step in drawing the graph of the derivative. Wherever our turning points used to be, we're going to trace them to the x-axis, either up or down, and they'll become our two new roots. Now, where is this blue line coming from? How do we know it's become a smiley face? If this equation wasn't here, how would we know the shape? So let's pretend that we can't see that was the equation there, or the original equation. How do we get the shape right of the new graph of the derivative? So look at my original one, the black one. We're interested in the movement of this shape before, between and after the turning point. Same as when we're doing stationary points. So up until our first turning point, our graph is always increasing. Now increasing means, if our graph is increasing, that means that we have a positive gradient. Now if you look at the first part of the blue line, that is above the graph, and if something has a positive gradient, we say that f dash x is greater than 0. So if my curve is increasing up to my turning point, then to my new root, before my new root, I draw that part of that line above the x-axis. Now between the 2 points, so between my two stationary points, notice that my black graph is decreasing. So when it's decreasing, that means that f dash x is less than 0. So in between those two turning points, I have to draw my curve below, and that's where I've got this lovely quadratic and new turning point below. And then after my turning point, my graph is increasing again. So my gradient is positive, so f dash x needs to be positive again, so that bit's drawn above. So it's remembering that the derived function is the equation for the gradient at any given point, okay? And when sketching the f dash x, you're sketching the gradient of your previous function. So here are the steps put in the simplest terms I can possibly think of. Step 1, look at your original diagram. Wherever your turn points were, you trace down the x-coordinates and they become your new roots. And it's very important, it's only the x-coordinates that are important here. Your y-coordinates mean absolutely nothing right now. Then you look at each stage of the graph before, between and after your previous turning points. And if the graph before is increasing, then at that little window before the turning point or between, we have to draw a new picture above the axis. And similarly the other way, if the bit of the graph we're looking at in the original is decreasing, then on our new graph it has to be drawn below. And a little tip is, we've all heard this phrase before, that if we say up above, down below. It definitely helps some of my pupils remember. So if the curve was going down the way, below, not de-low. If the curve is going down the way, we draw it below the graph. If it's going up, we draw it above the x-axis. So let's have a look at an example. Start really simple. So here's my first graph. We can clearly see that's a graph of y equals x squared. They won't be as simple as this, but it's a good place to start. So we can clearly see the station point is 0, 0, so my new root will be at 0, 0. There's step 1. I've drawn on where my root will be. Now before that turning point on the original graph, this part of the graph was going down the way. So my new diagram, that bit is going to be below. And then afterwards it's increasing, so that bit is going to be above. Now, if you differentiate x squared, f dashed x is just 2x, so we're expecting a straight line. So what we have is a straight line that up until the coordinate 0, 0 is below f of x, is below your x-axis, sorry, and then after 0 it is above the x-axis. And we all know what a straight line of 2x looks like. It's a slightly steep positive gradient line. Let's have a look at probably more similar to what you could be asked at high. So we've got one here now. Notice there's no equation whatsoever. It's completely irrelevant to us. So let's have a look at where our turning points are. We have a turning point at -1, 6. So I'm going to trace down to the same position in my new graph, and I'm going to put a root at -1. And then I've got a turning point at 1, -2. I'm going to trace that down, and I'm going to put a turning point at 1. So there's the first bit. We've put on where our new roots are. Now, we're going to look at each stage of the diagram. So before the turning point of 1, my graph was increasing. So I have to draw that bit above. So I'm going to draw above to there. Between -1 and 1, my graph is decreasing. So it's going down, so down below. So this bit has to be down below. And then after the 1, it's increasing. So it's going up, so it has to be above, up above. So remember, up above, down below. Now, I'm sorry, that is not the best shape. Let's just draw that shape again, shall we? My top tip would be to do these in pencil and then go back, because what we don't want to see is pupils having really jaggy looking quadratic graphs. So there is my thing, and all that's left to do is label this as this is the graph of y equals f dashed x. Okay, let's look at another one. Okay, so we've got this shape here. We have two turning points again. One of them happens to be a point of inflection, so we're going to get a different shape on this one. So first off, I'm going to trace down my turning points. So I'm going to have a root at number 4. Sorry, -4. And then the other turning point is on the x-axis, so when I trace that down, I just know it's going to be a turning point at 0. Before the first turning point, my graph was always increasing, so this bit is going to be above. So it's going to be above for the first bit. In between my turning points, it's going down the way. It's decreasing, so that's going to be below. And then after that, it's decreasing still, so that's going to be below again. So for the first bit, it's going to be above. Then it's going to be below. And then how do you make that below again? Well, it must mean that that's going to turn and go back down. Now, I'm not happy with that, so I'm going to draw that again. So it's coming down, back up and turning. Now that's not a wonderful diagram, but we get the idea. So this is a graph of y equals f dashed x. Right, let's look at a couple more. So these ones are similar, but just slightly different positioning. So I'm just going to quickly go through the steps again. So we've got a turning point here at 1, so I'm going to trace down and put my new root at 1. I've got a turning point at 3. So I'm going to have a new root at 3. Now these dotted lines, you don't need to have them. It's just me showing you my method and the way I do it, because I talk to my pupils all the time about tracing it down. That's not always possible in an exam paper, but it's a good place to start. So we trace them down. Before the first turning point, my graph was decreasing, so that's going to be below. Between the 1 and the 3, it's increasing, so that bit's going to be above. And then after the 3 is decreasing, so that bit is going to be below. And you know, obviously I'm not happy with that sketch, but now I know what kind of roughly shape it's going to be. I can go in and redraw it again. So I know it is going to look a bit like this. So an upside down quadratic. And that is the graph of f dashed x. Don't be put off. This one says g of x. No difference at all to it. But let's look at the method again. So where are my turning points? I've got a turning point at -2. And I've got a turning point at 4, so I can just trace that one down. So there's my two roots. Up until the number -2, my graph was increasing, so that bit is above. Between the 2 and the 4 is decreasing, so that means that bit's below. And then after that, it's increasing, so that means it's above. So I've got the idea of the shape for that one. I'm not going to have to redraw that one. I'm happy with it. Very quickly, I'll cut a couple more of these odd shaped ones. Now this one here, the first one is exactly like the one I did before. So it is increasing to 5. So my first turning point is actually, the 5 is irrelevant. It's a red herring. That turning point is on the axis, so my new root is on the axis as well. Second turning point is at the number 2. It's increasing up until my first turning point, so that means that bit's above. Then it's decreasing between, so that means below. And then it's decreasing after, so that means below again, so it turns. So that's exactly like my second example. Sorry about that. I've pulled these ones from past papers and we are limited to how many there are. Right, on this last one though, there's no numbers at all, there's just letters. So my first turning point is here at 0, so my new root is at 0. My second turning point is here, and they've called it B, so I'm going to trace down, and I'm literally just going to call that one B. So my roots are at 0 and B. Before the 0, my graph is increasing, so that bit is above. Between the turning points, my graph is increasing again, so that means this bit's got to be above. So I'm going to have to turn that into a little turning point and then bring it back. And then after the B, it's decreasing, so that means it is below. So I've got that kind of shape. Okay, I hope this has helped. These aren't that scary, but they do generally get asked most of the times, and it's a nice guaranteed 2-3 marks if you remember them, and that's the trick, is remembering the method. Thank you, bye bye.